Have you ever wondered why some harmonies sound disturbing, but others sound relaxing? Why music makes us emotional? Why musicians use scales? Why the names of tones repeat? Why tones with same names sound almost identical? A scientific paper published October 3, 2017 uncovers the probable answer to those questions. This easy-to-understand demonstration starts slowly, explaining what you need to know so you will understand the finale, where the discovery is revealed. When we talk about music, we always think about multiple tones that we hear at the same time, what we call harmony, or in a sequence, what we call melody. In both cases, they define a musical context which could sound pleasantly or not. Together with rhythm, harmony and melody are the most important features of music, so to understand the roots of our musical perception, we need to understand why some combinations of tones sound nice to us and others not. Musicians and scientists built a list of sounds made by combining two tones and ordered them by pleasantness. This is the so-called consonance pattern. Although the order of this list is widely agreed upon, no one was yet able to convincingly explain its essence, why we do like some sounds more than others. In this study, the authors Toshil Pankovsky and Eva Pankovska are suggesting the physical and physiological causes of consonance, for the first time in 2,500 years of pursuing this mystery. Their artificial brain model perfectly reproduced the consonance pattern. There are two main causes for consonance. The first one is the nonlinearity of the sound caused by vocal cords, musical instruments, particularities of the ears. The second one is the neuroplasticity of the brain. That is the brain feature that allows us to learn by repetition. The purest possible sound is called a tone. The tone is a wave of mechanical pressure traveling through the air, water, or any other material. In nature, there are never pure tones. All sounds are made of multiple tones, called harmonics, or overtones. These overtones, they are always accompanying the main tone. They enter together in the brain, never as one single tone. As already said, neuroplasticity is a feature of the brain that allows us to learn by repetition. So, the brain learns which tones are always accompanying the main tone, and since that is happening all the time, without exception, the brain is associating these patterns very, very strongly. The magic happens around the strengths of the neural associations between overtones and their main tone. If we measure them and order, we will get the exact list of consonants we saw previously. The details about how these associations are formed are fascinating, and can be read in the article. Later, when we listen to any sound that has an unusual pattern of overtones, our brain will be surprised, upset, and as other scientists proved, we will feel even a slight fear. Those sounds we call dissonant. The sounds that have the regular learned overtone pattern are not causing unpleasant feeling, are those we call consonant sounds. First and immediate consequence from this study is that the animals found at the higher position on the evolutionary ladder will experience the consonants similarly as us, humans. This means that you and your pet dog or cat should both feel the music you are listening to in a similar way. The essence of our musical taste is a learned behavior. However, because the most frequent overtone patterns found in nature are universal, no culturally specific experience can mess the order of the most pleasant sounds in the list. The most dissonant sounds are weak in the regular overtone patterns. They could be influenced by specific experiences, and that was confirmed by other scientists. Therefore, Nature defines the upper, most pleasant part of the consonant list, making it universal, but nurture may confuse the lower part, and it can differ from culture to culture. This study would not be possible without the result of past experiments, performed by other scientists. Those experiments used regular tones from musical scales, but our hearing is so sensitive, it can detect 30 sounds between two regular tones. So, to even more rigorously test this discovery, the authors would dive down to the limits of the hearing precision. The authors of this study continue with their research. They started an online listening experiment, down to the very precision of the human hearing. To achieve that, they need a massive amount of data, which will be used to better validate this discovery. You, also, can take part in this online experiment. It is easy, it is free, and it is fun. Simply go to brainexperiments.com, and follow the instructions. In addition, you may share a link of this video with your friends and relatives, and help to bring many to take part, since the experiment needs thousands of listening sessions to be performed. Thank you for helping the advancement of science, and the discoveries about the essence of music.